Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children. I've shared my screen. Is it visible?
Yes, ma'am.
Yeah. Okay. I had opened a few presentations. Now, this is what you can see, right? An elastic belt is placed, correct?
Yes, ma'am.
Yeah. Okay.
Mm.
Yeah, children, actually, today's class was supposed to be on circles, but I was like reworking on the presentations. So that's just like almost done, but it's not ready to be used for the class today. So I'm, like actually doing areas related to circles. We'll go back to circles in the next class. Okay. Yeah. So this is areas related to circles. And the question is, an elastic belt is placed around the rim of a pulley. Okay. So this is the pulley. This is the pulley. Okay, an elastic belt is placed around the rim of a pulley of radius 5 centimeters. Radius 5 centimeters. One point on the belt, elastic belt, no? So see, there's a circular pulley, and there's an elastic belt around the pulley. Now, one point on the belt is pulled directly away from the center O. What you do know that elastic belt, you pinch a little and you stretch it away from the pulley. Okay, imagine that. So like pulley is that the one you see above a well where the rope runs through the pulley, right? The rope is tied to a bucket, and how is the movement of the rope managed by the pulley, the circular pulley? So like that, on such a pulley, there's an elastic belt, and what you do is you pinch a little portion of the belt and you pull it away from the center O until it is at point P. So please imagine that. So this is the pulley. This is the pulley, the circular pulley with center O and radius 5 centimeters. You pinch this portion of the belt. Okay, you pinch it and you stretch it away from the pulley. So at this point, you pinch the pulley and stretch it away from the pulley to this point P, so that the distance OP is equal to 10 centimeters. So that the distance OP is equal to 10 centimeters. Find the length of the belt that is in contact with the rim of the pulley. So now when you stretch this away, no, now what is the length of the elastic belt that is still in contact with the rim of the pulley? This one. This is the length of the elastic belt that is still in contact with the rim of the pulley. Now, because you pinched and you pulled a little of the belt away, this one will stretch like this, right? This will stretch like this. So here the elastic belt is not in contact with the rim of the pulley. Okay, because you've stretched it away from the center O. So that's the question. Find the length of the belt that is in contact with the rim of the pulley. Also find the area of the shaded region. You can see this region is shaded, right? Find the area of the shaded region. All right. So circle, which is the pulley here, center O, radius 5 centimeters. The distance OP is 10 centimeters. We'll have to find two things. One, the length of the elastic belt that is still in contact with the rim of the pulley. That is the length of the major arc. The length of the major arc. Two, we have to find the area of the shaded region. Area of the shaded region. So, we need to know the sector angle. That's very important to find the length of the major arc. To find the length of the major arc, we need the sector angle, right? So here, please go through this. We found the sector angle here. And after finding the sector angle, we find the length of the major arc ARB. We find the length of the major arc ARB. First, we need to find the sector angle. Trigonometry. Then, once you have the sector angle, find the length of the major arc ARB. Okay. Now we need to find the area of the shaded region. Area of the shaded region. So area of the shaded region is like, you can do it in two ways. See, you can do area of this triangle. You can do it in two ways. Area of this triangle. This one is a right triangle, correct? Because this is 90 degrees. Radius, tangent, perpendicular to each other. So one way of finding the area of the shaded region is find the area of this right triangle using the formula half base into height. Okay, this is the base and this is the height. And the height can be found using Pythagoras theorem, because you know the hypotenuse is 10 and you know this leg is 5. Using Pythagoras theorem, you can find AP, and half into base into height will give you the area of this triangle minus the area of this sector. This sector angle we have found here, it's 120. This full thing. So the half of it will be 60 degrees. Half of it will be 60 degrees. This angle is 120. Okay, so this will be 60 degrees. This will be 60. So find the area of the right triangle and find the area of this sector with sector angle 60 degrees. Area of the triangle minus the area of the sector will be the area of this shaded region. Into 2 will be the area of the entire shaded region. Multiply by 2, double it is one way. Or what you can do is you can find the area of this quadrilateral. You can find the area of this quadrilateral minus the area of the sector with sector angle 120 degrees. Area of this quadrilateral. How do you find the area of the quadrilateral? It is 2 into area of the right triangle. It is 2. Area of the quadrilateral is 2 into area of one right triangle. Area of the right triangle into 2 is area of the quadrilateral. So find the area of the quadrilateral and subtract the area of this sector. Subtract the area of this sector with sector angle 120 degrees. And that will give you the area of the shaded region. Yeah, please work this. Is very important question. Please work this, children. Write down the question. Please, the calculations, you can just take it from here. You don't try to cancel and all that. And then this final answer 20.93 and things like that, you know, that you just copy from here. Don't spend time on multiplying. You'll finish it in less than 5 minutes. I'll just come back. Completed, children? Children completed this one? I hope all of you understood how to find the sector angle. To use trigonometry, you need a right triangle, and here we have a right triangle. Radius perpendicular to tangent, right triangle. And in this triangle, we know two sides. OA is 5 centimeters and OP is 10 centimeters. So in a right triangle, you need two things. Okay, so when you have two knowns, then you can find the unknown. So what is the unknown? You are interested in finding the sector angle, this full angle. You want to find the measure of this whole angle, but it's okay. Using the right triangle, you can find half of it. You can find this portion. Once you find this angle, double it to get the complete angle. Complete angle meaning this full angle AOB. So that's what we have worked here, 60 degrees, and then this is 60 degrees. So this full angle is 120 degrees. But then we have to find the length of this major arc. So the angle corresponding to the major arc is this angle, which is 360 minus 120, 240 degrees. So 240 by 360 into 2 pi r, not pi r square, 2 pi r, because length of arc. The angle corresponding to the major sector. 240 by 360 2 pi r will give you the length of the major arc, which is the length of the elastic belt that is still in contact with the rim of the pulley. Okay. Next one. This I'll just present the answer. We'll read the question, understand the information given, and then I'll present the answer. You need to help yourself, and then we'll discuss. Arc A is a part of the circle with center O. Arc A. Okay, this one. This is arc A. This is arc A. Okay, arc A is a part of the circle with center O. Okay. So that means, see, this is the arc A. And you can see that P and Q are points on arc A. So that means from the center to any point on the arc is the radius of the arc. Is the radius of the circle of which the arc is a part. Let's see that again. Arc A is a part of the circle with center O. Okay. So now like just complete the circle. So what are P and Q? They are points on the circumference of the circle. So that means PO should be the radius, right? Any point on the arc connected to the center is the radius. Any point on the arc connected to the center of the circle is the radius of the arc. So this is arc A. P and Q are points on the arc A. So PO, QO are the radii of the circle of which this arc is a part. Arc B is a part of the circle with center M. Okay. Arc B, this is arc B, and that's a part of the circle with center M. With center M. See here. Now P is what? It's a point on the PQ. P and Q are the points on arc A. Now for arc B, M is a center, where M is arc B is a part of the circle with center M and radius PM. And radius PM. It's given. Arc B is a part of the circle with center M and radius PM, where M is the midpoint of PQ. Find the area enclosed by the two arcs. That is, find the area between the two arcs. Find the area between the two arcs. Okay. So what you have to do is, you need to find the area of the sector. First, you need to find the sector angle. We don't have a right triangle. You have to find the sector angle. Okay, so you cannot use trigonometry here because we don't have we don't have a right triangle. You need to find the sector angle. Then find the area of this sector. You need to find the area of this sector. All right. Yes. Okay, you need to find the area of this sector. Then area of the sector minus the area of the triangle will give you the area of the segment. Area of the sector minus the area of the triangle will give you the area of this segment. Now, area of this region, this region minus the area of the segment will be the area of the shaded region. Now, can anyone tell me the sector angle? Can anyone tell me the sector angle? What is the sector angle?
Ma'am.
Correct, Swati. Very good. 60. Why?
Because it's an equilateral triangle.
It's an equilateral triangle. Very good. Because it's an equilateral triangle. OP is 10 centimeters, OQ is 10 centimeters. And you can also see this is 10 centimeters, 5 plus 5, 10. So this is an equilateral, OPQ is an equilateral triangle, and hence the sector angle is 60 degrees. Yeah. Please help yourself and present the answer slide. Okay, one thing I didn't tell you, children. So look at this. Now in a circle, now supposing we take a chord, okay? And if the center lies on that chord, then that chord is a diameter. In a circle, if the center of the circle lies on a chord, then that chord is the diameter of the circle. Now see here, the center cannot lie here, no? See, this is the center. So now the center lies on this chord. That means this chord is the diameter of the circle. If the center of the circle lies on a chord, then that chord is the diameter of the circle. All right. So here it's given that I just missed to, you know it, but I just missed to, say that. Now here it's given that M is the center of this arc B, and M is the midpoint of PQ. M is the midpoint of PQ. M is what? The center of arc B. Okay. And M is the midpoint of PQ. You even see here, M is the midpoint of PQ. M is the center and M is the midpoint of PQ. That means PQ is a diameter. That means this arc is a semicircle. This arc is not a semicircle. This one is not a semicircle. Okay. This one is a semicircle. See, this is a semicircle because which is the center of this arc? M. M is the center. Okay. And what is M? It's the midpoint of PQ. The center M lies on the chord or lies on the line segment PQ. That means PQ is the diameter. So that means this is the semicircle. Yeah, please continue. Take down the question, draw the figure, go through the answer, understand, and then work out. Calculations, just take it down from the slide. Completed, children?
Yes, ma'am. Yes, ma'am.
Okay. So we found the sector angle because it's an equilateral triangle. The sector angle is 60 degrees. Okay, so the area of the shaded region is area of the semicircle. Area of the shaded region is area of the semicircle. The radius of the semicircle is 5 centimeters. So area of the semicircle, circle is pi r square. Semicircle is half pi r square. And radius is 5. So area of the semicircle minus the area of this segment, this region, this white portion, segment. Area of the semicircle minus the area of the segment will give you the area of the shaded region. So area of semicircle easy to find. Half pi r square, we know r is 5. So how do you find the area of the segment? Area of the segment is area of the sector. Area of the sector minus the area of the triangle. And how do we find the area of the sector? Theta by 360 into pi r square. 60 by 360 into pi r square. Where r is 10 children. R is 10. For the semicircle, the radius is 5. For the semicircle, radius is 5. For this sector, for the sector, the radius is 10. See here, OP is 10. Okay, so be careful while substituting the values. So area of sector is equal to 60 by 360 into pi r square, where r is 10, minus area of the triangle. It's an equilateral triangle, so root 3 by 4 into side square. That will give you the area of this portion. Then the area of the semicircle minus the area of the segment will be the area of the shaded region. This we already did it in a class earlier. Yeah. This is just one line answer. Let's see if you can tell me what I am expecting. So in this figure, the side of the square is 28 centimeters and the radius of each circle is half of the length of the side of the square, where O and O dash are the centers of the circle. Find the area of the shaded region. Find the area of the shaded region. The entire thing is shaded. What's the side of the square? 28. This is 28. And what's the radius? Half the length of the side of the square. So 14. The side is 28, the radius is 14. Yeah. Tell me the expression to find the area of the shaded region. I just wanted to say this one plus this one plus this one. Like that. Without having to subtract anything. I don't want something minus something plus something minus something. I don't want that. I want something plus something plus something like that. Just addition. I'm waiting for the answer from your end. Please think. Excuse me.
I'm 2 times the area of 3/4 of the circle plus area of square.
Correct. Correct. Thank you, Swati. Very good. So we know that the angle here is 90 degrees. So this angle is going to be 270 degrees. So the area of the shaded region is area of the two major sectors. This is a major sector. This one is a major sector. This one is a major sector. This one is a major sector. The angle here is 90 degrees. So this angle is 270 degrees. So the area of the shaded region is area of the two major sectors with the sector angle 270 degrees plus the area of the square. Let's draw the figure like this. See, this is the shaded region. This is the shaded region. This is the shaded region. So the angle, this is 90, so this one is 270. So here this is 90, so this one is 270. Ignore this portion. This one ignore. Ignore this which is inside the square. Ignore that. So this is 90, so this is 270. 270 and area of the square. So area of the shaded region is equal to 270 by 360 into pi into r square is 14 square. Like this into 2 plus the area of the square, 28 square. Area of the square is a square, 28 square. Plus we have two major sectors and the angle in the major sector is 270 degrees. So 2 into 270 by 360 into pi r square, where r is 14. Yeah, please take down. Done, children? Okay,
Yes,
the
ma'am.
next one. Okay, next one. Yeah, I want you to find the radius of the semicircles. What is the radius of the semicircles? What is the radius of the semicircles? Okay. So 3 plus R plus 2R plus R plus 3 is equal to 14. Is equal to 14. See here, semicircle. So this is a diameter. This one is a radius. Semicircle, this is the diameter. This is the radius. Okay, so this is the radius. This is the diameter. Diameter, radius, diameter, radius. All right. So what is the length from here to here? 14. So 3 plus R plus 2R. Diameter, no, this is 2R. So this will be 2R plus R radius plus 3 is equal to 14. So like that you can find the value of R. And what will be the area of the shaded region? How will we find? Now you got R. Okay, what's the value of R? 2. R is 2. So how do we find the area of the shaded region? Shaded region is this blue portion, this one. Okay, I know you know it, but you're just hesitant to say. So it will be the area of the outer square minus the area of this design inside. There's a design inside here, right? There's a design here. Area of the outer square, ABCD. Area of the square minus the area of this design will be the area of the shaded region. So what is this design made up of? It's made up of 4 semicircles. That means 2 circles and 1 square. 1 square. The design is made up of 4 semicircles. 4 semicircles. That means 2 circles and 1 square. So area of the outer. So what's the area of the design? Area of 2 circles plus area of 1 square. That answer. Keep that answer. Now, area of the outer square minus the area of the design will be the area of the shaded region. Yeah, please do this. Please work. Done, children?
Yes, ma'am.
Are we writing, all of us? Blessy, finished writing? Have you written the question, taken the diagram and the answer?
I have to draw the diagram.
Okay. Okay. So as you can see here, we first found R, then the area of the outer square, then the area of the unshaded region. This is the unshaded region. The total area minus area of the unshaded region will be the area of the shaded region. Because what is the total area made up of? Shaded region plus unshaded region. Shaded area shaded area plus unshaded area is equal to total area. So the total area is 196. From this, if you take away the area of the unshaded region, you will get the area of the shaded region. Yeah. Try this. The short and long hands of a clock are 4 centimeters and 6 centimeters long, respectively. Find the sum of the distances traveled by their tips in 2 days. The short hand is the hour hand. The long hand is the minute hand. So it's not the seconds hand. Short hand is the hour hand. The long hand is the minute hand. You must find the sum of the distances traveled by their tips in 2 days. In 2 days. Now let's look at the hour hand. Okay, hour hand, 4 centimeters. Now the hour hand is now at 2. Say now it's 2 in the afternoon. Now it's 2 in the afternoon. Okay. How many circles will the hour hand make in 2 days is what we have to find out. Because if it makes one circle, area is pi r square. Sorry, not area. No, so sorry. Find the distance traveled. So 2 pi r. 2 pi r. If it makes one circle, the distance covered is 2 pi r. Because the tip, what distance will the tip cover when it makes one circle? 2 pi r. The tip will trace a circle, right? The tip will trace a circle. So when it traces one circle, when the tip of the R hand traces one circle, the distance covered by the tip is 2 pi r. Okay, now how long will the R hand take to go one complete circle? No, I think I lost the track of my question. Sorry, that's why this. Okay, so I was here actually. Now it's 2 in the afternoon. Okay, now where is the hour hand? It's at 2. The minute hand is at 12. The minute hand is at 12. Okay, this is 6 centimeters. The hour, now we are talking only about the hour hand. The hour hand is at 2. It's 2 o'clock in the afternoon, it's at 2. Now the hour hand has to come back to 2. Then it's made one full circle. The hour hand has to come back to 2. Then it makes one circle. So when will it come back to 2? at 2 in the night, that is, past midnight. Afternoon 2 o'clock, then past midnight, early morning, okay, early morning, the V hours, early morning 2 o'clock. Then when will it again come back to 2? In the afternoon. So afternoon and then early morning. So see here, it's at 2, the hour hand. So it needs 12 hours to make one circle. Hour hand needs 12 hours to go one complete circle. That means the hour hand, the tip of the hour hand travels 2 pi r in 12 hours. In 2 days, how many 12 hours? 4 12 hours. So 4 into 2 pi r is the distance traveled by the tip of the hour hand in 2 days. The hour hand needs 12 hours to go one full circle. When it goes one full circle, the tip of the hour hand has covered a distance of 2 pi r. So 12 hours it needs to go one circle. Then the distance covered by the tip is 2 pi r. So how many 12 hours in 2 days? 1 day 24 hours. 2 days 48 hours. So how many 12 hours? 4 12 hours. So 4 circles it will trace in 2 days. So 4 into 2 pi r is a distance covered by the tip of the hour hand in 2 days. Now coming to the minute hand. The minute hand, now again, coming back to 2 o'clock in the afternoon. Where's the minute hand? It's at 12. At 2 o'clock in the afternoon, the minute hand is at 12. When will the minute hand come back to 12? When the clock strikes 3. When the clock strikes 3, okay, when the clock strikes 3, the minute hand will come back to 12. When will it again come back to 12? When the clock strikes 4. So every hour, the minute hand needs just 1 hour to go one full circle. Every hour, the minute hand is tracing a circle. 2 o'clock, the minute hand is at 12. Again at 3 o'clock, after 1 hour, it will come back to 12. It will go 5, 10, 15, 20. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Every hour, it's tracing a circle. So that means in 1 day, 24 circles. In 2 days, 48 circles. One circle, 2 pi r. 48 circles, 48 into 2 pi r. But what is r? 6 centimeters for the minute hand. For the hour hand, 4 centimeters. Yeah, please work this. You can just take it as small r and capital R, children. You don't have to write length of the shorthand, length of the long. You can just take 2 pi small r and 2 pi capital R. So what I've done is, I've found the answers in pi. I've not used 22 by 7 because it's not divisible, no? So I've found the answer in pi. So 32 pi, 576 pi. Then I add both, I get 608 pi. Now, once for all, I use the value of pi 22 by 7. So you can save time in calculation. Every time using 22 by 7, and then maybe you'll find the decimal value or, okay, whatever you do, so you're going to spend a little extra time there. So don't use the value of pi. Find both the answers in pi and add. And once for all, here you use the value of pi. Two pi small r. 2 pi capital R. It's time. It's time, children. I'll share the image on WhatsApp. You people have school tomorrow. Take your time. The image is on WhatsApp. Most of this we have done. Okay. I'll share this one also on WhatsApp, children. Please complete this also. A circle of radius 28 centimeters is inscribed. It's inside a regular hexagon. Find the area of the hexagon outside the circle. A circle of radius 28 centimeters is inscribed. It's inside a regular hexagon. You need to find the area of the hexagon outside the circle. That is this portion. Area of the hexagon minus the area of the circle. Area of the hexagon minus the area of the circle. So for the circle, you know the radius is 28. For the hexagon, you need to find the side. Because how do you find the area of a hexagon? It's made up of 6 equilateral triangles. So 6 into root 3 by 4 a square. A regular hexagon is made up of 6 equilateral triangles. So area of a regular hexagon is equal to 6 into root 3 by 4 a square. Because root 3 by 4 a square is one equilateral triangle into 6. So clearly the answer is area of the hexagon minus the area of the circle. Circle, we can find the area because we know the radius. Hexagon, we need a root 3 by 4 into side square. Side, we need the side of the hexagon. So that can be found using trigonometry. We need to find this one of the hexagon, this side of the hexagon. And that can be found using trigonometry. Okay, so I'll just share this also on WhatsApp, children. So it's the area of the hexagon minus the area of the circle. Circle, we know the radius. Hexagon, we need to find the side, and that is found here using trigonometry. And we know the angle here is 60 degrees. So half of that 30. Because 6 equilateral triangles, no? 6 equilateral triangles. So 60 degrees, 60 degrees, 60, 60, 60, 60. So this is 60. So 30, 30, because the two triangles are congruent. Then use trigonometry, find AM and double it to get AB. All right. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.